So in today's class, we'll discuss linear regression, that is the first supervised machine learning model. Okay, so it is a supervised machine learning model. Okay, and its output is continuous value. Okay, linear regression output is continuous value. In this linear regression, we'll cover two type of linear regression. That is first one is simple linear regression. Okay, linear regression, and second one is multiple. Okay, multiple linear regression. So linear regression is a statistical method used to model the relationship between dependent variable and one or more independent variable by fitting a linear equation to observed data. We'll see this definition by a example. Okay, mathematical representation is y equal to mx plus b. Okay, it is the equation of line. So here m is the slope and b is the intercept. Okay, so in this linear regression, we mm, first suppose it is a model. Okay, so model, you give some weight. Suppose you give some input that is weight and you predict the height. Okay, so it is training dataset. Training dataset. Okay, so it is weight is the dependent variable and here height is the independent variable, and it is the model of linear regression. If you give the weight, then it predict the height of a person. Okay, so it is a simple example, okay, of linear regression. So to create a best fit line in such a way, the summation of error should be minimum. So we create a best fit line, okay, so that the error should be minimum. Suppose you draw um, a data set. Okay, take. Suppose a data set is uh, suppose a data set is weight and height. Okay, weight and height. Suppose in this data set given weight is 74, 80, such as 75, etc. Okay. After that, height is given according to weight 170, 180, 170. Okay. Suppose you draw this data set 74 in weight 74, height is 170. So in 74, height is 170, and some point here, and some point here, and some point here, and some point here. So you draw this point like this. Okay, suppose it is your height and it is your weight. Okay, and you draw a line so that the error is minimum. If you draw a line, so the perfect line will be like this. Okay, so it is the linear regression. Okay, so here you know the equation of this line is y equal to mx plus c. Y equal to mx plus c. Okay, here m is the slope and b is the intercept. Okay, so the model, okay, the model learns the coefficient, that is coefficient is weight during the training process to minimize the error between the actual output and the predicate output. The aim of the linear regression is to fit a best fit line so that the error should be minimum. Common technique for training include ordinary, least square, that is gradient descent, and stochastic gradient descent. For each different method, we'll discuss later. So, okay. After that, suppose I discuss one example that is a data set. Okay, given a data set that is so before we discuss the data set, we discuss the different cost function. Okay, so cost function is used to minimize the error. Okay, so first one is suppose data set is theta 0, theta 1. Okay, so 1 by n summation of I equal to 1 to n mm, actual minus predicted square. So here it is a formula of mean square error. So it is a formula of mean square error. Okay, mean square error. Mean square error. Okay, so here yi is actual value. Okay, we'll discuss with the example later. Okay, here a theta of x equal to predicted value. Okay, and n equal to number of data point. Okay, so here n equal to number of data point. For final goal, in order to get the best fit line, so in order to get the best fit line, we'll minimize the error. For best fit line, for best fit line in linear regression, we'll minimize the error. Okay, here the error or cost function is mean square error. Okay, so we'll discuss with an example. Okay, suppose a data set, we'll give in a data set. Okay, so data set is x is one feature and y is another feature. So 1, 2, 3 is x value, then 1, 2, 3. Okay, accordingly, this will draw. Okay, a line. Okay, we'll draw a line. So here that is 1, 2, 3. 1, 2, 3. 1, 1. So it is x and it is y. So point is here, and then next point is here, and next point is here. 3, 3. Okay. So line will be like this. Okay. Okay. So here line will be like this. So the equation is y equal to mx plus c. So here we write like this. So s theta of x equal to theta 0 plus theta 1x 1. Okay. Here x1 is the x feature and theta 0 is the intercept and theta 1 is the slope. So let's here you assume theta 0 equal to 0. Okay. So a theta of x equal to theta 1 x1. Okay. So here we will notice if x equal to 1, if x equal to 1, then s theta of x equal to 1. If x equal to 2, then s theta of x equal to 2. Okay. If x equal to 3, then s theta of x equal to 3. Okay. because h theta of x equal to that is y. Okay, so here we discuss with three example how this line will be minimum. Okay, if you calculate accordingly, so here you notice, so we know that a theta equal to theta 1 x1 because we assume mm, theta 0 equal to equation is a theta equal to theta 0 plus theta 1 x1, and we assume theta 0 equal to 0. So equation is a theta equal to theta 1 x1. So at x equal to 1, we notice at x equal to 2, we notice at x equal to 3, we notice. Here assume theta 1 equal to 1, and we assume theta 1 equal to 0.5, and you assume theta 1 equal to 0. Okay, so you notice at theta 1 equal to 1, so after that theta 0 equal to 0, a theta equal to theta 1 x1. Okay, so here theta 1 x1. So theta 1 equal to 1. Then 1 into 1 that is 1, 1 into 2 that is 2, and 1 in 3 equal to 3. You put in this formula, you will get this value. Okay, after that in 0.5, you will notice 0.5 into 1 that is 0.5, that is 1, that is 1.5. Okay, if theta 1 equal to 0, then all the value is 0. Okay, so if you apply this in mean square error, that is formula is 1 by n summation of s theta minus s theta of x rho whole square. So here first one is j of x equal to 1. Okay, that is theta 1. So theta 1 equal to 1 by 3 equivalent to 1 minus s theta of x, that is 0.5. Okay, 0.5 ka whole square plus 2 minus 1 whole square plus 3 minus 1.5 whole square. If you calculate this value is 1.16. If you calculate h of theta 1, that is 1 by 3. Okay, theta 1 equal to 1. So 1 minus 1 whole square. Actual value is 1. Predicate value is 1. So 1 minus 1 whole square plus 2 minus 2 whole square plus 3 minus 3 whole square. This value is 0. If you calculate j of theta 2, that is 1 by 3 whole into that is theta 0, that is 1 minus 0 whole square plus 2 minus 0 whole square plus 3 minus 0 whole square. If you calculate this value, that is 4.66. So here you notice, if you assume x equal to 1, then the error value is 1. Sorry, 0, and if you assume x equal to 2, then error value is 1.16. If you assume x equal to 3, then error value is 4.66. Okay, so here we notice the minimum error value. Here you notice when x equal to 1, the minimum error value is 0. Okay, so we draw the best fit line at x equal to 1. Okay, so it is the conclusion. Okay, after that we'll okay. So here if you notice, okay, okay. So if you notice the error value is here, and then error value is here, then error value is here. At a time, error value is minimum. Okay, it is going convergence algorithm and error value will be minimum at some point. Okay, it is the gradient descent. Okay, it is gradient descent. Okay, at a point you will find the global minima. Global minima. Okay, if you find here 0, here 1.16, etc., etc. is 4.6. Okay, so at a point you will find the global minima. So when you will find the global minima, it is the best fit line for linear regression. Okay, so we'll discuss what is convergence algorithm. Okay, so convergence algorithm we'll discuss. Okay, optimize the change of theta 0 and theta 1. Okay, here is optimize the change of theta 0, theta 1 to global minima. To global minima. Okay, we'll see in this algorithm, in this diagram, it is a global minima. Okay, okay. Here it is the global minima. So, okay. So repeat until convergence. Okay, it will be repeat. Okay, repeat until to find global minima, that is convergence. Okay, so this formula is theta j or theta I minus alpha del theta j by del theta I. We'll discuss this. This is the gradient descent. Okay, this is the gradient descent. We'll discuss in neural network. Okay, we'll discuss this in neural network topic, artificial neural network, ANN. Okay, when we will discuss ANN, we'll discuss gradient details in detail. What you know, it is the convergence algorithm for optimizing just change of theta 0, theta 1 for finding the global minima. Okay, so in linear regression, we will, okay, after the all the process, you will find the model evaluation. After training, the model performance need to be evaluated using metrics such as mean square error, okay, such as mean square error, mean square error, and we'll discuss mean square error formula with a example, okay, and another is root mean square error, that is RMSA, okay, root mean square error. Okay, RMSE also discussed in next lecture. Okay, then R square, that is the coefficient of determination. Coefficient of determination. We'll discuss in next class. Okay, so these metrics help assess how well the model fits the data and makes prediction. Make prediction. Okay, so when you got to prediction, one strength and evaluate the linear regression model can be used to make prediction on new data by inputting the features values into the model equation. If you input the value, okay, then you find the actual output. Okay. After that, linear regression assumes linear between the variable independent of error, okay, constant variance of error and normality of error. So after that we'll notice types of linear regression. Linear regression generally are two types. First one is Simple linear regression, here one independent variable. Okay. After that, multiple linear regression, here multiple independent variable. So we discuss simple linear regression with example. Okay. In previous slide. Okay. Now we'll discuss multiple linear regression. Okay. Multiple linear regression is same as simple linear regression. Here difference is more than one independent variable that's depend. Okay. In multiple regression, there are multiple independent variable that is x1 to x2, x3, xn. Okay, up to xn, and one depend variable that is y. Okay, here one depend variable plus multiple independent variable. Okay, but in simple linear regression, one dependent variable plus one independent variable. Okay, so in simple linear regression, the equation was y equal to mx plus c. Okay, but here y equal to b0, b1 x1, b2 x2 plus up to bn xn. Okay, plus epsilon. Epsilon is intercept. Okay, so it is the equation of multiple linear regression. It is same as simple linear regression. Here you can apply the mean square error, okay, means absolute error, root mean square error. So we'll discuss all the performance metrics in the next class. Okay. So in today's class, so we'll discuss some application of linear regression such as sales forecasting, stock price prediction, house price prediction, or demand forecasting. Okay, it is the normally चार application of linear regression. Okay, so mm, in today's class we'll discuss simple linear regression. Okay, then we will discuss multiple linear regression at last. Okay. Then you also discuss mean square error. Okay. So with an example. Okay. In next class, we'll cover here uh, that is R square, adjusted R square, and types of cost function that is mean square error, means absolute error, root mean square error, and also discuss the important part that is overfitting and underfitting. Okay, and also discuss reach, lasso. Okay, we'll discuss this topic in next class. Okay, so thank you.